Section 3.1, tangent lines and the derivative at a point. This is the first section of this chapter 3. Chapter 3 is about the derivative. Derivative means rate of change. For example, let's say you have a function. This is the graph of a function. You would like to find out the changing rate of this graph at any point. Then basically you are trying to find the derivative of that function at that particular point, which can be found by finding the tangent line, by finding the slope of the tangent line at that particular point. So you draw the line. This line is called tangent line at point P. Slope of the tangent line, this tangent line at this point, is actually rate of change of this function at this point, which is also called the derivative. So in our real life, we can think about, we can model, for example, let's say uh, population of a city is changing, and we can model that population by using some function. And now we would like to find out what is the rate of change of the population in that particular city. And by finding that information, we would like to approximate what would be the population of the city after 10 years. In that case, we need to find out derivative. Okay, that's just a simple introduction. So now to find out the derivative, we need to find out the slope of the tangent line. And slope of the tangent line can be found by using this limit. The slope of the curve y equal f of x at the point P, where x0 is the x coordinate of that point and the value of the function at that x0 is the y coordinate of the point, is the number, this number, which is actually the limit of this expression, provided the limit exists. If this limit does not exist, then we cannot find the slope. Provided the limit exists, it means the limit does exist. This is the slope of the tangent line. Tangent line to the curve at point P is the line through P with this slope. So here is the curve f of x. Here is a point P, x0 and then y0, where y0 means it's the value of the function at x0. And we would like to find out the slope of the tangent line. This line, say t, it can be found by finding this limit. Okay. If you cannot find this limit, that means you know finding the slope of this tangent line is not possible. Now, by using that information, we can define the derivative. The derivative means it's a rate of change. The derivative of a function means we are interested to find the rate of change of that function. The derivative of a function f at a point x0, we denote this derivative by using this notation, which is called f prime of x0, which is basically notation for the derivative. That is actually slope of the tangent line at that point. So the derivative of a function f at point x0 is f prime of at x0, and that is equal to the limit of this expression. So derivative means slope of the tangent line, and slope of the tangent line can be found by using this limit. Okay. So now, because we know slope of the tangent line means derivative of the function at that point, and so the derivative and then slope of the tangent line, they are same thing. So the following are all interpretation for the limit of the different quotient. So different quotient means this expression is called different quotient, and if the limit of this different quotient exists, then we can say that the slope of the graph of y equal f of x at x0, the slope of the tangent line to the curve y equal f of x at x0, the rate of change of f of x with respect to x at x0, the derivative f prime at x0. So they are, all these things are same thing. Either you say rate of change, or you say derivative, or you say slope of the tangent line. All of them are same thing. So in this section, we're going to do a couple of examples. The first example is find an equation for the tangent line to the curve at the given point. Then sketch the curve and then tangent line together. So this is the curve. Function is 4 times the square root of x. This is the point we have given. So whenever we try to find out the tangent line, this is what we have to keep in mind. This equation of a line with slope m and passing through a point x1, y1 can be found by using this formula. Y minus y1 equal m times x minus x1. M is the slope and then x1, y1 is 1 point on that line. So we are going to use the very same formula for finding the equation of the tangent line. So to find the equation of tangent line, we need to find the slope. And now to find the slope, we need to find this expression, this limit. Okay, so slope of this function can be found by finding this limit. And remember, this x0 in this case is 1. So slope m can be found by finding this limit of the function at x0, which is 1 plus h. So look at here, I'm just replacing this x0 by the point we have given, which is x, which is 1 in this case, and there is a h minus f of x0. So the value of the function at 1 over h. So this is the function. So we are going to calculate this value. Y means it's f of x, which is 4 times the square root of x. We need to find out the value of the function at 1 plus h. So just replace this x by 1 plus h. We need to find out the value of the function at 1. For this one, just replace this x by 1, so which is 4. So just plug this value back here and find out the limit. Limit h approach to 0, 4 times square root of 1 plus h minus 4 over h. Now when we try to find the limit, we have to just simplify this thing first before plugging h equal to 0. Because if you try to plug h equal to 0 as it is, then this function, this value would be undefined. So what we do, we can just factor out this 4 and take this factor out here, and we can just write down 1 plus square root of 1 plus h minus 1 over h. And to simplify this, we just have to multiply the numerator and denominator by conjugate of this term. Conjugate means the same thing, but in the middle term you just change the sign. Okay, if you do that, now you can just simplify on the top. Eventually we would like to cancel this h. That's the whole point. So I need more space here, so I'm going to just add one extra page. Let's go here. Slope m equal 4 times limit h approach to 0. If you multiply this one and this one on the top and distribute them, it will give you 1 plus h square root of 1 plus h square minus 1 square over h times square root of 1 plus h plus 1. So now if you simplify on the top more, it would be 1 plus h minus 1 over h times square root of 1 plus h plus 1. So you can cancel this one and this one. There is a h on the top, there is a h on the bottom, so you can cancel that, meaning you are dividing h by h. So eventually on the top there will be 1, and on the bottom there is h inside this radical sign. So now we can find out the limit by plugging h equal to 0 here. So if I plug h equal to 0 here, it will be 1 plus 0 plus 1, which is eventually 1 over 2, which is eventually 2. So slope of the tangent line we're looking for here at 0.14 is 2. So we found the slope. Now we are going to use this formula. Remember, x1 means 1 and y1 means 4. It's given here. So we are going to use that formula. The equation of tangent line can be found by using this formula. Now y1 is 4, slope we found that's 2, and x1 is 1. So just distribute this 2, bring this 4 to the right side. Then eventually we're going to get y equal 2x minus 2 plus 4, which is y equal 2x plus 2. So that is the equation of tangent line at point 14. That is possible, by using this formula. In this formula, we need to find out the slope. Slope can be found by using this limit formula. Let's go to another problem. Find the slope of the graph of the function. So this is the function. We want to find out the slope of the graph of this function at point 420, and then find the equation of tangent line to the graph at the point. So this is exactly same problem. The only difference is we have given different function and different point. So the slope, again, we are going to use this formula y minus y1 equal m times x minus x1, and then we're going to find out the slope m, which is limit h approach to 0 o plus h minus z4 over h. So we need to find out this expression. We can simplify it the way we simplified before. Then after that, by using this formula, we can find out you know uh, the equation of tangent line. So let's see here. G of, let me just do it here. G of 4 is just plug x equal to 4 here, which is 5 times 4 over 4 minus 3, which is basically 20 over 1, so which is 20. And z of 4 plus h, which is 5 times 4 plus h over 4 plus h minus 3, which is eventually 20 plus 5h over h plus 1. Good. So z 4 plus h is, this is 20 plus 5h over h plus 1, and then g of 4 is 20. So we need to make, you have to simplify this. Simplify this, we can make the same denominator here by multiplying the numerator and denominator by h plus 1. By doing that, as you can see here, because they have the same denominator h plus 1, we can just write down 20 plus 5h minus, distribute this 20h minus 20 over h plus 1. This h also can be written as, the h here. That's the same thing. Okay, so I need extra space one more time here. So let's continue. Slope, limit h approach to 0. If we go back here, that would be this 20 cancel out. 5h minus 20h is negative 15h over h, and then there is h plus 1. We can cancel out this h. Now if we try to find out the limit, this h goes to 0, so eventually it will be 15 over 1, which is negative 15. So the slope of the tangent line at point 4 comma 20 for this curve is negative 15. So now we can find out the equation of tangent line. Y minus y1 equal m times x minus x1. Y1 is, it's a point, this is the x y coordinate 20, slope is negative 15, x coordinate is 4. So this is, if you distribute this negative 15x, and negative 15 times negative is negative 60, there is a negative 20, so we can just add 20 here. Y equal negative 15x plus 80. So this is the equation of tangent line. So here is another problem. Find the point xy. We have to find this point xy at which the graph of this function has a horizontal tangent line. So remember, horizontal line means this kind of line where the slope of the line would be 0. For any horizontal line, slope would be 0. So what we have given is, find out the slope of this curve and equate that slope with 0 because the slope should be horizontal tangent line, and solve that equation for finding x and y. So there is a curve at some point xy, there is a horizontal line. We would like to find out this point where the curve has horizontal tangent line. Okay, we would like to find out, this is the curve, for example, there is a tangent line and the point on the tangent line is x comma y. We would like to find out this point such that this tangent line is horizontal. So what we have to do is we need to find out the slope of this curve. The slope can be found by using same formula, h approach to 0, the function x plus h minus the value of the function over h, and this is the slope. We know that slope should be 0 because the slope of the horizontal tangent line is 0. We know that slope is 0, it's given. So let's find out this different quotient. This expression is called different quotient. Find out fx plus h. This is f of x. F of x is 9x squared plus 9x minus 8. Fx plus h is, just replace wherever you see x, just replace that x by x plus h. So 9 times x plus h minus 8, and then just simplify that. So x plus h square is actually, it's x squared plus 2xh plus h square, plus if you distribute this 9, it will be 9x plus 9h, there is a minus 8. So this is the value of fx plus h. I'm going to copy this value down here, and when I copy, I just distribute this 9 as well. If I do that, it will give me 9x squared plus 18xh plus 9h squared plus 9x plus 9h minus 8. That's the value of fx plus h, minus the value of f of x is 9x squared, but because there is a minus sign in front, we need to change the sign of everything here. It will be 9x squared negative 9x positive 8. Divide it by h. So as you can see that the good thing is we can cancel this some of the terms like negative 9x, positive 9x, positive 8 and negative 8, and eventually we can simplify the numerator such that we can have h factor on the top. 1, 2, 3 terms and all of them have h. So I can factor out h here, and for this one the leftover would be 18x, this one the leftover would be 9h, for this one the leftover would be 9 because I factor out h. So now we can cancel this h and this h. Now eventually we can find out the limit by plugging h equal to 0 here. So this part would be 0. So eventually it will be 18x plus 9. So this is the slope of this curve at any point x. But we are interested to find the point where the slope is 0. So just make this slope equal 0. Um, so let's go here. The slope should be 0. So we found that 18x plus, that's the slope, plus 9 equals 0. Now we need to solve for x. 18x equal negative 9, and if we divide both sides by 18, x would be negative half. So we are going to have slope 0 when x is negative half. If x is negative half, what would be the value of y? The value of y can be found by plugging x equal to negative half here. So x is negative half. We know y is 9x squared plus 9x minus 8. So 9 negative half squared plus 9 times negative half minus 8. So this is 9 negative negative positive because we're squaring it. So it gives us 9 over 4 minus it gives us 9 over 2 and it gives us 8. So to make the same denominator, we can multiply the numerator and denominator of the second term by 2 and numerator and denominator by the third term by 4, so that we can have same denominator. That's just the simplification process. So on the top, that's 9 minus 18 minus 32. 8 times 4 is 32. So if we simplify this, 32 minus 18, that will give us 50, 50, negative 50, positive 9. So that will be eventually negative 41 over 4. So at point xy, where x is negative half and y is negative 41 over 4, the slope of the tangent line on this curve, uh, you know, uh, would be 0. That means there will be the horizontal tangent line. So this is our final answer. Finally, this is the application problem. Uh, an object is dropped from the top of a cliff 600-meter high. So there is a cliff, let's say this is the cliff, and something, we are just going to drop something from the cliff, okay, and it's going down now. So this distance of this something, uh, can be modeled by using this quadratic function, which is 600. Let's say this is function of x, function of time. Function of time is 600 minus 4.9 t square, which is the function of, this is actually height function. So this is what we have given. An object is dropped from the top of cliff 600-meter high. So this is 600 meter. This is 600 meter. It's going down. Its height above the ground t seconds after it is dropped is this function. Determine its speed 6 seconds after it is dropped. So after, when t is 6 second, what is the speed of this object? So one thing you have to keep in mind, speed is actually absolute value of, the slope of the tangent line. Speed is absolute value of the derivative. So velocity means it's a derivative, but the speed means it's absolute value of the derivative or slope of the tangent line at that point. So what we're looking for here is, we know the slope can be found by using this limit formula. By using this limit formula, absolute value of that slope is actually speed. So let's say slope for this function is limit when h approaches to 0, the value of the function at 6 seconds, so it should be 6 plus h minus the value of the function at 6 over h. So find out the value of the function at 6 plus h, and minus, find the value of the function at 6, and then find out the limit, this limit. Eventually you can see that it will be negative. If you simplify this, eventually it will be negative, that will be negative, negative, what is that, 9.8 times 6, which is negative 58.8. Okay? But that's the slope. If you simplify this, this is what you are going to get. Okay, and the simplification is exactly similar to the simplification I did before. So I'm going to skip that simplification, just plug the value. Eventually you're going to get this. This is the slope. The speed means absolute value of this. So the final answer, the speed is, if it's negative, make it positive. 58.8 meter per second. It's a meter per second. That's the speed. Okay, so that's our